Dear students, today we will discuss Theorem 1.29. Okay, so in this theorem, we will extend a result which we had earlier. Okay, if we had a simple measurable function, we know how to define a measure. Okay, suppose we have a simple function, say s. Okay, then we have defined psi of e, which is equal to integral over e s d mu. Okay, and we had shown that this psi was a measure. Now with the help of monotone convergence theorem, we generalize this result. Okay, we don't need a simple function. We can generalize that into any positive measurable function. So we can generalize this as into any positive measurable function f. Okay, so theorem says that suppose f from x to closer interval 0 infinity is measurable, and psi of e equal to integral over e f d mu, where e belongs to m, then psi is a measure on m. And also integral over x g d psi, which is equal to integral over x g f d mu for every measurable g on x with range in this closer interval 0 infinity. Okay, so we prove this theorem. So first we want to show that this definition psi is a measure on m. Okay, so first property, you will find psi of phi. What is psi of phi by definition? Integral over phi f d mu, which is equal to 0. Why? Because we have mu of phi equal to 0. That is, if we integrate over a set of measure 0, then we will get a 0. Okay, so that's why psi of phi equal to 0. Now the second one is countable additivity. Second, countable additivity property. Okay, so for this we take disjoint sets, say e1, e2, etc. Okay, these are from our scriptum, and whose union is e, that is union ej, where j varies from 1 to infinity equal to e. Okay, now since ej's are disjoint, okay, then we have chi e, which is equal to summation j varies from 1 to infinity chi ej. Okay, why this equality? Since ej's are disjoint, because of that we have chi e equal to 1 if x belongs to e. Okay, so if x belongs to e, this means what? We have x belongs to sum of ej. Okay, now since ej's are disjoint, so that means x belongs to only one ej. Okay, so that is equal to 1. So that's why this equality is chi e, this is equal to summation j varies from 1 to infinity chi ej. Okay, now what is chi ef? This is equal to summation j varies from 1 to infinity chi ej f. Okay, now we can write psi of e by definition integral over e f d mu. Okay, so this can be written as by again by using definition we can write integral over x chi e times f d mu. Okay, so what is this chi e times f d mu? We can write this chi e as sum of chi ej. Okay, so that is equal to integral over x sum of chi ej, where j varies from 1 to infinity, times f. Okay, d mu. So from previous result we can interchange this sum, we can take the sum outside. Okay, so that is equal to summation j varies from 1 to infinity integral over x chi ej f d mu. Okay, so that is equal to summation j varies from 1 to infinity, okay, integral over ej by definition f d mu. Okay, so what we have proved that psi of e equal to summation j varies from 1 to infinity. What is integral over ej f d mu? What is psi of ej? This is equal to by definition integral over ej f d mu. Okay, so this is this one, so that is equal to summation j varies from 1 to infinity psi of ej. Okay, so this means this psi is countable additive and therefore psi is a measure. Okay, now the second part of this theorem, that is integral over x g d psi, that is equal to integral over x g f d mu for every measurable g on x with range in closed interval 0 infinity, which is left as an exercise for you. Okay, so here if we substitute g equal to chi e for some e belongs to our scriptum, okay, then this result holds. Okay, so this result holds for every simple measurable function g. Okay, so for the general case we use monotone convergence theorem. This is the hint for the proof. So you prove this. Okay, this left as an exercise for you. Okay, thank you.